Hello and welcome to MacLearn 360. In this video, I want to solve a problem with you to illustrate the concept of a force which is in space and its component along the x, y, and z direction. So let's read the problem together and solve it. So we are to determine the magnitude. So we are to determine the magnitude and direction of the force. Okay, so this force that we are talking about is having a component along the x, which is 320, and then newtons, and then a component along the y, which is 400 newtons, and finally a component along the z, which is minus 250 newtons. So the question is, how can I find the magnitude and then the direction? So number one, we said that if I have a force which is in space, then it has a component Fx along the I plus a component Fy along the J direction plus a component Fz along the K direction. Is that right? And then we also said that these forces are related by what we call the direction cosine, given by F cosine, the angle which the force makes with the x-axis, plus F cosine, the angle the force makes with the y-axis, plus F cosine, the angle the force makes with the z-axis. Now we are saying that this, so in other words, Fx, the scalar is actually Fx equals F cos theta x. And then Fy is going to be F cos theta y. And then finally, Fz is going to be F cos theta z. And this F, which we are saying here, is actually the resultant. It's actually the resultant or the magnitude given by the square root of x squared plus y squared plus z squared. So if I want to find the magnitude is going to be the square root of the component of the force along the x, which is actually 320. So 320 squared plus 400 squared, and then I'll do plus minus 250 squared. And what is that? Let's pick our calculators and do this together. So I'm going to get, that is the square root of 320 squared plus 400 squared plus minus 250 squared. All right. So that is 570. So it means that the magnitude of this force is 570 newtons. Now, if I want the angles, in terms of the x direction, I have cos theta x to be Fx divided by F from this relationship, so that I can say that theta x is going to be cosine inverse of Fx, which is 320 divided by 570. And then I'm going to get, so let's pick our calculators again. Cosine inverse of 320 divided by 570. And that is 55.847. So 55.847 degrees. Okay. And then cos theta y is also going to be Fy divided by F. In other words, theta y is going to be cosine inverse of 400 divided by 570. And what is that? So that is going to be cosine inverse of 400 divided by 570. And what do I get for that? I'm going to get 45.43. 45.43 degrees. And then finally, I'm going to do cosine theta z is Fz divided by F. And therefore, theta z is going to be what? Cosine inverse of minus 250 divided by 570. Is that right? So then I'm going to get to cosine inverse again of minus 250 divided by 570. And what is that? I'm going to get 116.01. So 116.01 degrees. So the pulse is having a magnitude 570, sorry. So it means if I try to illustrate this force, what we are saying is that this force is actually having a component, let's say, along the x direction, and then a component along, let's say, the y direction, and then the z direction. And then this force is actually in space. So let's say that this force is in space. This is not in this plane, please. But we are saying that this force is having a magnitude of 570 newtons, and then it makes an angle 55. So it makes an angle 55.847 with the x. It makes an angle. This angle is 45.43, and then it makes an angle 116.01 with the z. Now you have to note that this is not necessarily in a quadrant. All right, this is not necessarily in a quadrant. But what we are saying is that this is in space, and the force is making an angle, this 55 with the x-axis, 45 with the y-axis, and then 116 with the z-axis. That's basically what we want to do. Thank you very much for watching.